inside every engine, cars, jets, rockets. There's a hidden force that makes combustion far more unpredictable than most people realize. A microscopic swirl of air or a single fuel droplet slightly out of place can completely change how an engine behaves. And the reason why is one of the most mind-bending ideas in all of physics: chaos. Combustion looks smooth from the outside, but inside the chamber, the flame twists, folds, and branches like a living organism. These tiny distortions grow rapidly, and the engine amplifies them with every cycle. This is the signature of a chaotic system, one where small differences don't stay small. Chaos doesn't mean randomness. It means the system is so sensitive that tiny changes explode into huge effects. Double the fuel doesn't simply double the power. A tiny shift in temperature doesn't cause a tiny shift in pressure. Everything interacts with everything else, and the result is beautifully unpredictable. There's a simple equation that captures this explosive sensitivity. It's called the logistic map, and it looks like this: x sub n plus 1 equals r times x sub n times 1 minus x sub n. X sub n is the system right now, the current state. X sub n plus 1 is the next step, what happens 1 moment later. The r term controls how sensitive the system is. And the 1 minus x sub n part represents the limits, the things that push back. At low values of r, the system settles into a stable pattern. Increase r, and it starts oscillating. Increase it a little more, and the behavior suddenly splits, then splits again, and then erupts into full chaos. Combustion follows the same pattern. When the system enters a chaotic regime, the flame becomes hypersensitive to microscopic variations in turbulence, fuel droplets, and temperature. That's why high-performance engines sometimes misfire, even when everything looks perfect. It's why knock can appear suddenly at the edge of the tuning envelope. But chaos doesn't stop at engines. The atmosphere works the same way. A tiny gust of wind or a patch of warm ground can grow into a completely different weather pattern. That's why forecasts fall apart after about 10 days. The equations don't fail. The chaos simply overwhelms them. Once you see it, you can't unsee it. Chaos shows up in ecosystems, population growth, electrical grids, financial markets. Any system where feedback loops amplify small changes. Engines just happen to be one of the most dramatic examples we can watch in slow motion. And here's the real takeaway: chaos isn't a flaw. It's a feature of complex systems. It's why engines need sensors, feedback loops, and real-time adjustments. It's why weather models constantly update, and it's why predicting the future of any chaotic system becomes nearly impossible beyond a certain point. So the next time you hear an engine stumble or you see the weather forecast suddenly change, remember this: the universe is full of systems where tiny changes matter, and sometimes they matter more than anything else.